Hi everyone, this is Unit 2, and in Unit 2 we are talking about exponential and logarithmic functions. Up to this point we've been doing a lot of linear functions. Those functions, again, just kind of make a line. And now we are working with exponential functions. If you watched the news during COVID, you probably saw a lot of these. It talked about how quickly the virus was, how quickly the virus was spreading in our society. So let's talk about exponential functions. So characteristics. Again, f of x is just y. Let's zoom in. There we go. That's fine. C is a variable, a is a variable, and x is a variable. But x and y are interconnected in that x is the input, y is the output. And x can be basically anything, and y depends on all of these calculations that are happening. What we need to identify for each exponential function is what is c and what is a. C is always going to be your initial value. Basically, that means, what did we start with? Like, did 5 people start with getting infected with COVID? And then once we have that initial value, we say, well, how quickly is it spreading in this case? So A is the growth or decay factor. And factor is a number that's basically going to be multiplied. That's A and that's C. Now, again, C and A are going to depend on the situation and the context. But A will really dictate if this function grows or decays. It will grow if A is larger than 1. And it will decay if A is between 0 and 1. Do note that a lot of fractions and decimals are between 0 and 1, but just because it's a fraction or a decimal doesn't mean that it's automatically between 0 and 1. We'll see an example of that in just a moment. But the first thing I want to do is see if we can identify some attributes of these functions. So we want to identify the initial value. Again, that initial value is always being multiplied. And the growth factor is the one that is with the exponent, the value that is with the exponent. It will be always, it's called a base, that base number with the exponent of x. And then again, if we want to identify whether it grows or decays, we are looking at that growth factor, that a value, and if it is bigger than 1 or between 0 and 1. 3.5 is larger than 1, so this function will grow. Again, growth means basically it's going up. I'm going to put a G here. Decay means it's going down. The output is decreasing over time. Sometimes we see this in populations where maybe a population of a town has been decreasing. So as one example. All right, I'm going to let you do this one. 1/3 is between 0 and 1. So again, that's a decay. The key to these notes are online. I will not do all of these examples. With my in-person class, I let them do these on their own, so I'll let you do these on your own as well and check the key. I'm going to go ahead and do this one, though, because this one's kind of a special case. Well, I shouldn't say special case, but kind of looping back to something I said earlier. The initial value is that number out front, in this case 3. The growth factor is that value that is with the base of x, 5/3. 5/3 is approximately 1.66. Again, just because it's a fraction doesn't mean it's between 0 and 1. This is bigger than 1, so this is a growth. I'm going to let you do this one. The one thing I would caution is if there is no value out front, you can say the initial value is 1. There's technically a 1 being multiplied in front of that 0.25, even if you can't see it. Okay, so that is if we have the functions, we can identify some attributes. If we don't have the function, if we, let's say, just have a table, and then later on we'll see if we just have a graph what we can do. So we can answer some questions about this function. We can see if it's increasing or decreasing. When we answer this question, we are looking at the y values. We're looking at the output and what the output is doing. So as the x increases, the y is also increasing. It's getting bigger. Now, with linear functions, we would be adding or subtracting a constant. So maybe plus 3 plus 3 plus 3. As you can see, that's not going to work here. 3 plus 3 is 6. 6 plus 3 is 9, right? We're not adding. Instead, we're multiplying by a factor, and we need to identify what that factor is. In some instances, you can just look at this and say, 3 times what is 6? 2. 2 times what is 12? 2, right? This pattern continues. If you can verify something works 3 times, you know that it works. It's a pattern. So my decay factor is my growth factor is 2. And it's a growth because it is bigger than 1. But what if you can't identify that it's being multiplied by 2? Well, that's okay too. To find your A, we just need to divide the outputs. If we can get from one output to the next by multiplying, we can figure out what this constant factor is by dividing. And you're always going to divide the larger output by the smaller output. What I mean by that is I would divide 6 by 3, or 12 by 6, or 24 by 12. So 6 over 3 is 2. If you accidentally switch these, let's say you did 3/6, you would get 1/2. And then that would be weird because it was increasing, but then the A was smaller than 1, and those contradict each other. So that's kind of your way of checking. If your A value should align with whatever's going on here. It's going to increase if A is bigger than 1. It's going to decrease if A is between 0 and 1. For initial value, all you need to look at is your y-intercept. Look at the y-intercept. Okay, sorry, that's a little blurry. What is the y-intercept? If you don't know, y-intercept is where it crosses the y-axis. Wherever something crosses the y-axis, the x value is always 0, right? Like this point could be 0, 3. We didn't move any in the x direction, but we just moved in the y direction. That always tells us the initial value. That's like a very easy way of seeing that. So if we have the y-intercept, great. I know my initial value is 3. If we don't have the y-intercept, then I will show you how to do that next. So again, the equation is c times a to the x. If my c is 3, this equation is going to be 3 times 2 to the x. Now I can figure out beyond this table, if x is 8, what my output would be. If x is 20, what my output would be. So we have created the equation. Okay, here we go. Let's do this again. This time, unfortunately, we do not have a 0, but that's okay. So I can again, and then I'm going to let you do this next one. I can look down here and say the y values seem like they are decreasing. They are getting smaller, which means that this factor needs to be between 0 and 1. Let me zoom this in. See if that will work. Okay. So let's do what I said earlier. Remember, I'm going to divide this one divided by the other one. The bigger output, the bigger x output with the smaller x output. So what would that be? That would be 250 divided by 500, which is 1/2. You could have done 125 divided by 250, 62.5 divided by 125. Any of these work. And it works this way because x is being counted by 1 right now. So I'm looking at exactly one factor to the next. So you can also kind of look at this and say, you can reason through it. How do I get from 500 to 250? I divide by 2. But something to keep in mind is that a factor is always being multiplied. So the same thing as dividing by 2 is multiplying by 1/2. So our decay factor is 1/2 or 0.5. We don't have our initial value, but that's okay. We can find it. Let me extend this table. I have 2, but I don't have 1 or 0. And I want 0 because that will give me my initial value. So if to go down, I need to multiply by 1/2, right? To go up, I do the opposite. Let's look. 125 times 2 is 250. 250 times 2 is 500. I can do the opposite if I go up. The opposite of this fraction is called a reciprocal. The reciprocal of 1/2 is just 2 over 1. Reciprocal just means the fraction is flipped. Another example, the reciprocal of 3/5 would be 5/3. So anyways, we're multiplying by 2 over 1, which is just 2. So to get from 500 to this next one, I'm going to multiply by 2. 500 times 2 is 1,000. I'm almost at 0. I need one more. Multiply by 2, 2,000. So my initial value is 2,000, and I can go ahead and create this equation, C times A to the X. 2,000 times 1/2 to the power of X. If I want to evaluate f of 8, that just means I'm plugging in 8 for X. So f of 8 is equal to 2,000 times 1/2 to the power of 8. All right. In our calculator, I'll go ahead and do this really quickly. 2,000 times, I'm going to do 1/2, and then to the power of is this little caret. Anytime you need to do an exponent, you can do this little caret. I'm going to press that, and it goes ahead and puts it in the exponent. So I'm going to press 8, and I get my value, 7.8125. All right. I'm going to skip this next one and let you do it. The answer is in the key. It is it's very similar to the one that we did beforehand. You need to find the factor, and then you need to find f of 0. Okay. Now I'm going to go on to this one. So if you've noticed up to this point, every delta x, every change in x has been 1. It's been 1, 2, 3, 4, 5, 6, but now we're counting by 2s. So earlier when we were finding a, it was just a equals, and then we would divide the 2 because it was only one factor. We were going from 1 to the next, which was just one factor. If, let's say, we jump from 2 to 4, we're basically skipping a factor and we're going 2. Like a has happened twice. It happened from 2 to 3 and 3 to 4. It's basically like a times a here. 2 factors happened, which is a squared. This works for anything. Like if you were going from 2 to 6, 4 of them were to happen, so you would say that's a to the 4th. And that's how you're going to find your factor. And that's okay. We can do this. So let's answer some other questions first. So this is increasing. And we need to find the factor. Okay. So because it's counting by 2s, I'm going to do a squared. And then I can do exactly what I did earlier. 324 divided by 144. And to find a, I need to do the square root. So again, calculator, second square root. Sorry. My computer almost froze. So second square root is above x squared. And then I'm going to do 324 divided by 144. I get 1.5. That is my A. A is equal to 1.5. That is also 3/2. If you don't know that and you want a fraction, you can press, sorry, this is going to be blurry. Come on, there we go. You can press math, the math button, enter, enter. It'll give you a fraction, 3/2. All right, now we need to, so this is, if A was counting by, like, from one A to the next, the factor is 1.5. So if I want to find my initial value, 1, 0, to get from 1A to the next downwards, I'm multiplying by 3/2. So to get back up, I need to multiply by the reciprocal, which is 2/3. So 144 times 2/3 is 96. Pretty sure. Yep, okay. Sorry. And then 96 times 2/3 again is 64. Again, that gives us our initial value. So 64. So that function is going to be 64 times 1.5 or 3/2, whatever one you want to use, to the power of x. I would suggest doing it in fraction form if you can in your calculator, because that will help you find the reciprocal and what you need to multiply if you need to go the opposite way. Okay, please pause the video if you need a little bit of time to sit with this. And we're going to keep going. All right. And we are getting close to being done. Don't worry, about 10 more minutes. Here we go. Given a table, 2 points or a graph, write the equation of the exponential function in exponential form. Okay, so this is, again, more work. Of course, it's more work. Sorry, words are hard right now. This is more examples of what we've just done. I'm going to give you a second to do this. You've already got your initial value, but your A is going to be increasing. It's counting by 2s. So I'm going to give you a chance to do this and see if you can do it. So please look at the key on this one. Well, I can just go ahead and write the answer for you, actually. And then if you want to see the work, you can look at the key. But I am going to do this next one. Okay, we've done ones that count by 1s. We've done ones that count by 2s. But now this one's counting by 5s. Like the x increased by 5. Let's zoom in a little bit here. And that's okay. That means to find the A value, we basically did 5 factors. So I've got to do a to the 5th equals that output, 3 divided by 96. I'm going to do the 5th root to solve this. To do a 5th root is the same thing as doing this to the power, whoops, that is yuck, sorry, to the power of 1/5. Let me move this mouse. So if I do that in my calculator, again, practice it like I mentioned earlier, do the little caret. If you put that in your calculator, 3 divided by 96 to the power of 1/5, I get 0.5. That is my A value. A is equal to 0.5 or 1/2. Okay? So to get 1 and 0, I'm going to do, instead of 1/2, I'm going to multiply by 2 to get those next 2 values. And if I multiply by 2, I get 192 and 384. So my initial value is 384. Let me zoom out here a little bit. There we go. 384 times 1 half x. All right. I'm going to go ahead and do another one. I'm going to set this one up for you. So if we're given just values, what can we do with these values? Well, again, these are x and y values. So x, y, or you can put x, f of x, so the point 0.04 exists and 112. We already have our c value. And it's stepping by 1, so I can go ahead and say 12 divided by 4 equals a. 12 divided by 4 is 3. And that's my equation. It's a little more difficult when I don't have the 0 and maybe it skips a little, but I can still do it. So if you want, I'll go ahead and do this one, but you can pause and see if you can do it. Okay. Okay. Yes. Okay. Sorry. I went ahead and put 0 because I know I want that one eventually. Probably should have put 1. Sorry. Let's do that. Okay. So we've got negative 1, 8, 0 something, 1 something, and 2, 1. That's all we know. So we skipped 3 points, right? From negative 1 to 2. 1, 2, 3 a's. So a cubed is equal to 1 over 8. If I cubed, oops, sorry guys. If I cubed root that, that's the same thing as 1/8 to the power of 1/3 in your calculator. If that doesn't make sense, that's a prereq skill. Please let me know. I'll find a video for you that explains that. And if I take that, then a is equal to 1/2. So a is going decreasing at a factor of 1/2. So I can go from here to here. I can go down and multiply this by 1/2, and I will get 4. And I've got my 0. Boom. So f of x is equal to 4 times 1/2 to the power of x. All right. Now, one more, graphically. Graphically, I can figure out what the initial value is with my y-intercept. So my c here is equal to 3. And then I can make a table and find a pretty point. What do I mean by pretty point? I wouldn't pick this point. It's like somewhere between 0 and 1 and somewhere it's at 4. But yeah, just find one that's got pretty values. So let's see. Looks like 1/6 has a pretty value. Let's do it. So if I make a table, I've got the value 0, 3, and I've got the point 1, 6. So my initial value is 3. And then it looks like from 3 to 6, I'm multiplying by 2. Again, you can divide them and you'll get 2. So this equation is y equals 3 times 2 to the x. All right. I'm going to go ahead and let you try this next one. Find pretty points. Find the initial value. Find the a, and that's all you need. Sorry, let me actually write the answer, though, in case you want to check your work without going to the key. But if you want to see it worked out, then you can go to the key also. All right. Here's just a little table that will help you with some of the vocabulary that you might see when you're approaching these problems. We always start with 100% in mind. So when we say increase or decrease, we're increasing or decreasing it starting with 100. So if we're increasing by 5, that means it's going to be 100 plus 5, which equals 105%. When you move decimal places, 105 is like 105.00. To move decimal places, you move it 2 places to the left, or you can divide this 105 by 100, and you should get 105. So that works too. Okay, I'm going to go ahead and do these. So decrease means we're going to subtract 5. Decrease by 15%. Again, we're doing 100 minus 15, which is 85%, or as a decimal, 0.85. If we're doubling it, that means we are multiplying it by 2, tripling it, multiplying it by 3. But what are we multiplying or dividing by 3? We're again doing 100. So 100 times 2 is 200%. That as a decimal is 2.0. Same thing with tripling. We're multiplying 100 by 3. So 300% or 3.0. Increased by 1/5. So what is 1/5 of 100? 1/5 of 100 is 20% or 0.2. So if we're increasing, we're adding. 100 plus 20 is 120%. That as a decimal is 1.2. Decrease by 1/4. We're subtracting it. 1/4 is 25%. Think of quarters. 100 minus 25 is 75%. That as a decimal is 0.75. Let's do a quick word problem, and I will let you do the second one. I will do the first one. So a population is initially 350. Find an exponential growth or decay model in terms of the number of time periods x if each time period in the population decreases by 7%. So our C is 350. Remember, all we need to do is create a model, which is the equation, and all we need for the equation is our C and our A. Our C was that initial amount, initially 350, and our A is the amount that it's decreasing by. Remember, what are we decreasing it from? 100. So if it's decreased by 7%, our A is 93%. As a decimal, that's 0.93. So again, 100% minus 7 is 93. And then I change that to a decimal. You can do 93 divided by 100, or you can move this 2 decimal places to the left. This is as an equation, the population P, so I'm going to do P of X instead of F of X, is 350, initial value, times A to the X. I'm going to let you do this next one, and I'm going to go ahead and show you the answer. Also, feel free to pause it if you want. And that is it for homework 5. This is enough. This should give you enough to do homework 5. Thank you so much. Please let me know if you have any questions.